everyone, my name is Salwa. I am a senior customs officer from Maldives Customs Service. In this virtual conference GPM 512, I am going to be talking about employing the use of full body scanners as a secondary security measure at both the domestic and international airports. This presentation would cover an introduction, how it works, SWOT analysis, current practices, and lastly, recommendations. Over the years, Maldives Customs Service has achieved remarkable progress and have brought numerous positive developments. However, with the various and fast-growing contemporary threats, including terrorism and transnational organized crimes, fast evolving and spreading across the globe, it is vital that we broaden the scope and scale of our enforcement operations. Hence, the installation of X-ray machines, baggage scanners, and metal detectors have become the standard in many countries. Maldives is an island nation stretched along to 26 atolls, with its unique demographic attracting tourists from all over the globe, making tourism the largest economic industry in Maldives. Every day, large volumes of people travel by the way of aircrafts, making the airlines as well as the airports attractive targets for terrorism and trafficking of human and illicit goods. Maldives Customs Service, along with other agencies, act as the first line of defense against various threats, including the smuggling of narcotics, weapons, and explosives. What is a full body scanner? A technological device that detects objects on a person's body for security screening purposes without physically removing clothes or making physical contact. Depending on the technology used, the operator may see an alternative wavelength image of the person's naked body or merely a cartoon-like representation of the person with an indicator showing where any suspicious items were detected. There are two types of scanners. First one is a backscatter scanner. Backscatter scanner uses a narrow, low-intensity X-ray beam directed at the target. Some of the absorbed X-ray generate a stream of low-energy photons back towards the scanner, which then creates an image of the target. Although it uses a low dose of radiation, which is a whole lot lower than a chest X-ray taken in hospitals on a daily basis, most of the scanners were replaced in airports around the world due to the health concern by the millimeter wave scanners. The second one is a millimeter radio wave scanner. This scanner is a whole body imaging device used for detecting objects concealed using a radio wave similar to the waves generated by cell phones. The radio wave sweeps the person and the antennas collect reflected waves and generate the image. Next up in the presentation is a short video outlining how full body scanners work in airports.
A body scanner allows us to use technology to screen passengers and to identify where on the body items may be concealed.
The Transportation Security Administration, or TSA, began placing body scanners in airports in 2007. In 2010, they were implemented into MSP.
The type of body scanner that we have here and we've always had here is called millimeter wave. It uses a technology, essentially a radio wave, that is bounced off the passenger's body to determine if something is concealed in their clothing or concealed on their body.
Unlike traditional metal detectors, body scanners are able to identify both metallic and non-metallic objects. When a person steps into the body scanner, they are directed to keep their feet spread apart and hands above their head. A rotating arm then moves around them.
That is when the radio wave is essentially bouncing off the passenger's body. It is not an X-ray. It cannot see what's inside the body. It's only detecting things on the outside of the body. It then takes that information and through an algorithm goes ahead and produces a generic image of the individual. And if there's anything that's been detected that's concealed, it shows up as a generic box on the generic image in the area of the body where the item was detected. Our officers then take that image and then just do a targeted pat down of that area to resolve what that alarm is, to make sure that it's not something that's harmful and that passenger is cleared to go. It's important to remember that we don't need to search the entire body because that has been cleared by the technology.
This results in massive amounts of time saved for passengers going through security lines.
The body scanner is designed to process about 240 passengers per hour. You know, if passengers divest all of the items from their pockets, they remove them as directed, keys, cell phones, paper, they can come into the body scanner, they have nothing concealed. They're literally cleared in a matter of seconds.
Dankers noted that the images generated are non-identifiable and never saved, and health risks are minimal to none, comparing the radiation from the scanner to that of a cell phone or radio.
Through intelligence and through experience, we know that explosives are the #1 threat against aviation. Often those are non-metallic in nature. Now, TSA uses more than just a security checkpoint, more than just a body scanner or a walk-through metal detector to detect these types of threats. We can do explosive trace detection. We can have canines that are trained to detect explosives. We have behavior detection officers. So we have many layers of security that are in play. This is just one of those layers. It is the most visible one, and it's one that we rely on heavily, but it's not the only one in place, and I think it's important for the population to know that.
Countries that installed scanners. The Netherlands was the first airport in the world to implement this device on a large scale after a test with flight personnel. Some of the other countries that installed these scanners are Malaysia, China, Japan, Australia, and the USA. Malaysia. Malaysians adopted the X-ray and millimeter wave scanners at the security checkpoints in early 2018. Since implementing in March, they have recorded an increase in processing speed by 2.5 times compared to conventional check-in counters. Malaysian Airports is looking to install additional units by the end of the year. China. Earlier in 2018, China reportedly rolled out 3D millimeter wave full body scanners, seen like in the pictures, across airports in the country. They stated that compared with the metal detectors widely employed at government buildings, public venues, and security checkpoints at airports and railway stations, the new scanners offer faster response time and higher accuracy with much less manpower needed. Japan. Japan has installed millimeter wave full body scanners in Kansai, Narita, and Haneda Airport in preparation for 2020 Olympics. According to the reports from Japanese officials, the scanners proved efficient and did not affect passenger flow rates. Scans were recorded to be performed in less than 20 seconds per passenger and in some cases just 10 seconds. USA. The most widely used of full body scanners is used in USA. In 2009, in the aftermath of the infamous underwear bomber, the Transportational Security Administration (TSA) moved quickly to update its screening procedures and technologies. By 2010, it had mandated the use of full body scanners in their airports. But with much controversy debate surrounding the backscatter machine and the health concerns, USA replaced all their backscatter X-ray machines to the safer option of millimeter wave scanners. Australia. In Australia's airport, full-body X-ray scanners was installed at screening points in 2018 under a major overhaul of Australia's airport security protocols following the alleged meat grinder bomb plot at Sydney Airport, which law enforcement officials have described as one of the most sophisticated terror plots ever hatched on Australian soil. SWOT analysis. SWOT analysis is a strategic planning technique used to help a person or organization identify strengths, weaknesses, opportunities, and threats related to a business, competition, or project. Strength. Enhanced level of security reveals artificially concealed items on the body, hidden under clothes, determining their size, shape, and position, detection of metallic, non-metallic, and liquids such as knives, lighters, and chemicals. It is more accurate than the old-fashioned passenger profiling. Weakness. It is very expensive. Each machine is estimated to cost between 150,000 to 200,000 US dollars. It does not reveal items concealed within body cavities. Legal and privacy concerns since it generates images of the person scanned. Health concerns due to the radiation used in backscatter X-ray machines. Opportunities eliminates the need of time-consuming pat-down or frisking. Enhance security measures in airports with a secondary layer of full-body scanners. Makes smuggling of contraband and illicit goods very difficult. Integrating ATR automated target recognition with the full body scanners in airports, this would provide an automated analysis eliminating the staff requirements. Threats. The effectiveness of scanners. Depending on the specific program used, it has been known to render it ineffective. Hacking. Like any technology, scanners use algorithms and programs which can be prone to hacking. Misuse of information. Current practices relied highly upon intel through multi-agency cooperation, passenger profiling, pat-down frisking, risk assessment plan in place for high-risk zone countries, backscatter scanners installed only in the main international airport, and lastly, passengers are scanned only if the person is suspected of concealment after conducting thorough interviews, manual baggage search, and protocols in place states that it can only be conducted with the permission from Commissioner. And lastly, recommendation. Mandating the use of full body scanners in both the domestic and international airport as a secondary level of security measure while relying on intel and metal detectors in place. This would enhance the security measures more. Applying the risk management plans already in place, providing technical services needed to maintain and operate the devices properly, developing a well-formulated and strict legislations to properly employ the use of full-body scanners, protecting social and ethical aspects revolving around privacy and information integrity. I hope this presentation has been informative and useful for everyone. Thank you for listening.